Test on Wednesday. Test will be similar format to quizzes. There will be some multiple choice type questions. There's plenty of those types in the workbook. What do we have? We have nomenclature of alkanes. Typically my test will begin with nomenclature question. What do we have? Lewis structures, right? Degrees of unsaturation, charges, formulas, all that associated with Lewis structures, yeah? You know everything we've covered. Physical properties, what's that? Melting point, boiling point, solubility, things like that. Acid-base chemistry. And cycloalkanes, alkanes, cycloalkanes, and anything else I didn't mention. Everything, right? Any questions about the test? Oh, including IR. IR will be there, similar to the workbook. Any questions about the test format on Wednesday? I'm not sure how many questions, typically about 4 pages, 4 or 5 pages. Yeah?
Do students usually complete it within like the 15 minutes that we have class?
Some do. Yeah. Yep. Just like an SAT or MCAT, there'll be students who are still working at the end. No, don't need a Scantron. Final exam, you'll need one. If you're well prepared, you will finish, yes. It is designed to be prepared, finished within the time allotment. Okay, guys, let's finish up the material looking at cyclohexanes. I think most of it's on the purple sheet. Chair or both conformations, chair is most favored because largely one diaxial interactions, chair is most favored. Cis or trans, we need to look at that. One thing we need to say is that the best positioning on your chair conformation is equatorial. For example, if you look at methyl cyclohexane, it can exist in 2 different ring forms. You could draw it like this with a methyl axial. You do a ring flip. Whenever you do a ring flip, all your axials become equatorial, right? And vice versa. So ring flip, this down, this up, this becomes equatorial. And these are your 2 major conformations. Your book may talk about intermediate conformations. I'm not going to talk about it. The 2 chair conformations are your main ones. And of the 2, having the group, the bigger group equatorial is most favorable. With this example, the ratio is 18:1. If you make the group even larger, like a tert-butyl, the ratio becomes 4,800:1. Even more preferred to be equatorial. Very reluctant for this to do a ring flip and come and exist like this. Largely why? Is because you have next door these these are up bonds. All 3 are up. This interaction here, it's called steric interactions. Whenever you have groups interacting, steric clash, steric interaction, or just sterics, that sterics is what's so bad. You don't have as much sterics when the group is equatorial. This is sometimes called 1-3, because if that's 1, that's 3. 1-3 diaxial, because they're both axial, interactions. Bad. The bigger this group is, the more interaction or bad steric interaction you're going to have, and the more prone it is to existing like that. You have two groups. Which is the most favored conformation? Well, you'd rather have your largest group equatorial. In this particular compound, they both cannot be equatorial. You do a ring flip, that becomes axial, that becomes equatorial. Which is best? Largest group equatorial. Turns you a little larger than a methyl. And when we say best, we're saying lowest energy conformation. Because these groups close together, that's higher energy, bringing the electrons close together. Let's see back up here, cis or trans. This compound here, are these groups cis or trans? Perspective drawing, we've already went over that, yeah? It's easy. Easy, right? If I draw one chlorine here, by the way, this is 1, 2, 3, 4, 1-4 relationship. Chlorine there, and I draw the bromine here. That's 1-4. Is that cis or trans? Trans, right? Okay, we went over that pretty easy, yeah? Well, what about this? Is this cis or trans? As we ended the last time, I showed you two H's that were cis and two that were trans. Okay? We'll do that again. The bromine, the H, it's above the H. The chlorine, the H, it's below the H. They're trans. See, if I was laying down here, this is me laying here on the sofa, okay? And I look up through here, that chlorine's coming towards me. Chlorine's coming towards me. The bromine's going away. That's the same as if I stood right here. The chlorine's coming towards me, the bromine's going away. It's the same compound, just drawn two different ways. Okay? Chlorine's coming towards you, that's what the bowl means. Okay? Well, if you're laying here, and say that's the molecule board there, the chlorine is coming towards you. It's just a different view of the compound. This H is coming toward you, but the bromine's going away. It's trans. That's the same compound. How about this compound? By the way, this is 1,4. 1,4 trans. That's a relationship between the two. If that's the one position, that's the 4. Now, nomenclature, you would have B comes before C, so that's really 1 bromo, 4 chloro, cyclohexane. Yeah? This is 1,3. But is it cis or trans? Cis, yeah? Everybody see that it's cis? Why? Because this bromine is up compared to the H, and that chlorine is up compared to the H. They're both up compared to the H. They're cis. Here, what do we have? 1,3 relationship. Cis or trans? The chlorine is down compared to the H. The F is up compared to the H. They're trans. Over here, the isopropyl group and the fluorine. We can't call this whole compound cis or trans because there's more than 2 groups, and so you don't know which ones you're referring to. But we can say, what about the isopropyl and the fluorine? Are those cis or trans? Isopropyl and fluorine. Cis. Yes. But then somebody's going to say, but that's equatorial and that's axial. And I would say, so? It has nothing to do with it. Yet students all the time come to me and say, but that's that and that's that. I'm like, I don't know. Why are you? No, that's not what we've ever done. I suspect that's what a TA has told you incorrectly. Be careful about things like that. All right? So some people will say if it's 1-4 and it's equatorial and axial, then it's this. Don't memorize every possible situation. Just do it like I did it here. Up or down compared to the H. That's all you need to do. Show in a perspective drawing. I showed this one in a perspective drawing. And we showed this in a perspective drawing. We could possibly end up with a mirror image. I'm not going to worry so much about that, although I will account for that. Okay, these two are cis. Yeah, I'm going to say if this is back, there's the isopropyl. Fluorine is next door. I'm going to go this way for a certain reason. Basically, I'm looking at it as if I'm laying up here. Isopropyl is back. The fluorine is also back, and it's coming, this ring here, this is 3D, hopefully you see that. Those are indeed cis. The bromine is 4 compared to the isopropyl, 1, 2, 3, 4. The bromine is trans to the isopropyl. We can do that by showing this here. And there's the same compound drawn in a perspective drawing. And the groups have the same perspective to each other, relative positioning. The two halogens are trans to each other, right? Everybody see that? Okay, how do we do on these? Show the following in the lowest energy conformation. One, two, three, let's see. Chair conformation. How do I do these? Okay, the two bromines are cis. The best conformation. Best is we want largest groups. Equatorial. What is the largest group? Bromine. I'm going to start and put the bromine here, equatorial. I like to draw in the H's at the carbon with the substituent. Put that equatorial. If I put the next bromine on, it now has to go here. Or there, 1, 2, 1, 2, 1, 2 could be 1, 2 or 1, 2. I'm going to put it here. If that one is equatorial, how's the next one? Well, it's cis, and that should be like this, right? Right? Aren't those cis? Both down compared to the H? Yeah, they're supposed to be cis. They're cis. If that one's equatorial, that one's axial. Then the fluorine has got to be either here or here. Either way, it would still be 1, 2, 3, or 1, 2, 3. I'm going to put it here. We can't worry about mirror image right now. I'm not going to worry about it. Let's not worry about it. Let's keep going. The fluorine is trans to the bromines. It's trans to this bromine. Trans to that bromine would be what here? That's an up carbon. And like this, trans be up, yeah? Just for the record, and we do have a record going here, that is the mirror image. We'll talk about such during test 2. Let's don't worry about it now. Question, is that the best confirmation? Or do we want to do a ring flip? Is that the best? Why is it not the best?
Because two groups are axial and one is.
Yes, we got 2 groups axial. One of the bromines is equatorial, that's good. What will the ring flip look like?
One really equatorial and one axial.
It will also have one bromine equatorial and one bromine axial, but the fluorine will be equatorial, yes. We do a ring flip. Now there's 2 ways to get to a ring flip from here. It depends on if we worry about mirror images or not. If we do an exact ring flip, pull this end down and this one up, that's going to be, and I'm not as good as drawing these. Pull this end down and this end up. We star this bromine, draw that bromine in now in the ring flip conformation. Okay, this bromine now is straight down. Everybody agree? And the H is like this. This bromine here is now here. That's a straight up bond. And we have like that. Those bromines are cis. Cis here. And the fluorine is here. That's a straight down bond, and it's a like this. And the fluorine is transferred to bromine, so it's like this. The bromines are cis, and the fluorine is trans to the 2 bromines, just like this. When we do a ring flip, everything went from axial to equatorial or vice versa. Which is better, right or left? On the right. In both cases, in each case, one bromine is axial and one is equatorial. Axial, equatorial, axial, equatorial. So that's equivalent. It's like a wash. So let's look at the fluorine. It's bigger than the H. Would you rather have it equatorial or axial? Equatorial. This is the best. And so at equilibrium, that one's favored at equilibrium. We had this one here. And I've got the mirror image. It's supposed to be this one on the board. That bromine is equatorial. This bromine is axial. Can you guys see that? Straight down. This fluorine over here, sitting right here. That's it on the board. See, that's straight up, and that's straight down, axial. But that bromine is equatorial. Can you guys see that? Okay. We have two groups axial. I did a ring flip. Pulled this down, put this end up. And this is supposed to be this one. Now that bromine over here on the point, that's supposed to be pointed down, is straight down. This bromine is now equatorial, coming towards you. And this fluorine is equatorial, also coming, well, it's equatorial. See, we lose a little 3D nature. That fluorine is actually coming towards you a little bit. But what we do have shown is that it is equatorial and not axial. So we did a ring flip, and this is the preferred conformation. The lowest energy conformation. Okay, how about the other one here? Again, that ended up being the mirror image of that. Let's don't worry about that for now. That's test 2. Okay? That's as if I was drawing a hand on the board, and this is the left hand, and then I started drawing a right hand. Still a hand. It's still got still the thumb is next to the pointing finger in both cases. Over here, chlorines are cis. Let's see. Isopropyl. Everything is cis. I'm going to do this a little bit different way. I'm not going to do a ring flip. And my first may be right or it may be wrong. I'm going to put the first chlorine equatorial. And this way, the second chlorine, is cis, so that's going to be axial. The isopropyl is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. The isopropyl is also going to be down compared to the H. This would be the best, yeah? Chlorine isopropyl equatorial, that chlorine axial. If we did a ring flip, then you would have that equatorial, but then you would have these two groups axial. That would not be as good. So this ended up being the best. And that there was the best. By the way, I could have did one other approach here. I didn't have to do it there because the first one was right. I can just tell it's right. And we didn't need to do a ring flip. Instead of doing a ring flip, if you're not worried about mirror images, and sometimes I may do this, and I could have did it here, that is, a lot of times I'll draw it the same here. The ring isn't the same way, except I'll just switch everything. There I started with the bromine equatorial, and it ended up being bad. How about if I start with the bromine axial? Then the next bromine is cis. Since they're cis, that means this is equatorial. And then the fluorine is next, and it's trans to those. It's trans to this one. For it to be trans, it needs to be straight up. And we have a good conformation where we have, hold on, that's not good. What did I do wrong? Oh, these are not trans. Bromine and fluorine are cis. That's wrong. That is a straight up bond, but the straight up would be the H. The fluorine would be trans to the bromine, so it would be equatorial. A little bit skewed here, but we know the equatorial is coming down because that's a straight up bond. And now we have two groups equatorial, and this is good. That's another way to do it. The problem is these two are actually mirror images. If you're not concerned with mirror images, that's okay. In this case, this is actually the right mirror image. And that's another way to do that if you're not concerned with mirror images. Instead of doing ring flip, use the same core structure or chair conformation, just go back and switch. Put the bromine here, the H here, bromine here, H here, F here, and H there. That's another way to do it. Or you can just do an old-fashioned ring flip and redraw it that way. Sometimes you may see me just do it like that. Okay, any questions on that page?
Yes, I have a question.
Uh-huh.
When attacking these questions, would you recommend that we first draw everything in as cis or trans, and then figure out whether or not they're our biggest groups are equatorial? I'm just trying to...
Well, that's what I did. I drew everything in and I looked at it.
Okay, so first figure out if they're cis or trans, draw them as such, and then make sure that the biggest groups are equatorial.
Yeah, and the two I did just that. It turned out not to be the best ones. I had to redraw it.
Okay.
I redraw it first time doing a ring flip, but then I came back and I showed you how I redrew it by keeping the chair the exact same, but just basically what I did to get here is instead of bromine here, I put the bromine there. You can just erase if you want, if you're using a pencil. Again, that's if you're not worried about mirror images. When I did the second one, I got the best confirmation the first time. I could have put the first chlorine axial. I put it equatorial because that's best. And that ended up leading to everything being best. Over here, I put the bromine equatorial because that's best. But because I put in equatorial, it made me had to put the other two axial. And I didn't realize that until I had already done it. So I had to redraw it. And again, two different ways to redraw. I didn't have to redraw that one. Okay, anything at all in the cycloalkanes? On the very back, once you get to biochemistry, you'll look at carbohydrates. Carbohydrates can be shown in open chain form or ring form. Carbohydrates are in equilibrium with open chain and ring. But the ring is a six-membered ring. It doesn't have an oxygen, but it's still a six-membered ring. And that six-membered ring is shown like this. That's a chair conformation. Back here, legs still over here. Okay, 1, 2, 4, 5, and 6. One of the carbons is an oxygen instead, and has no H's, of course. And in the ring forms, they have two different possibilities. This is called the anomeric hydroxyl group. If it's axial, straight down, it's called the alpha anomer. If the OH is equatorial, it's called the beta anomer. But to understand this terminology and to deal with all this, you first have to understand chair conformations and how to draw them, and the terminology, cis and trans, and axial, equatorial, etc.
So would the beta anomer be better, since everything would be equatorial, or is it just, does it really not matter?
I haven't had biochemistry in a long time. My first thought with it would be better, unless something's going on. I can't remember, unless hydrogen bonding makes this better for some reason or something. Does it show an equilibrium here? Answers that? Well, it actually does, yeah. It shows, this can go to two different ring forms. The beta anomer or the alpha anomer is 63 to 37. So it's like twice as favored. The beta anomer, the OH is equatorial. That would be the main reason. Unless there's other reasons that we talked about in that course. So this material is a prerequisite for biochemistry discussion here. Okay, any questions about the test at all? Any questions at all about material? That's the end of the material. Yes?
And what's the difference between steric strain and torsional strain?
I don't know that I can tell you. I use the term sterics for all of it. There's probably a slight difference. What is your difference?
I was working on number 13. So for the boat confirmation, the cyclohexane, it asked what's the interaction between the black cohydrons, and I thought it would be torsional, but the answer is steric, so I was just confused.
Torsional was an option?
Yes.
Why do you think it would be torsional?
Because in the book, when I was talking about the Newman confirmations, it said when they were eclipsed, that was torsional strain. So
Yeah, I'm not exactly sure the difference. I've never clarified the difference. You may know better than me from the reading. Let's look at it a little closer. Since there is a question in there, we'll make sure it's right. Sterics. I don't know the precise difference. One of them may be more due with atoms, and the other may be more due with electrons. With atom being the nucleus.
Newman confirmations in torsional strain? Well, if it's rotating on that sigma bond, it'd be torsional strain for those two large groups to be right next to each other. So it would be a torsional strain along that rotating bond, maybe. But in like the boat confirmation, the cyclohexane, it's going to be steric because there's no way for it like to turn, right?
Okay, but torsional does refer to me a little bit that it's rotational, because you have the torsional angle. So it may involve if it's able to rotate. Let's look at it closer. Yeah. Question?
In the book, it was just defined as the energy difference between the staggered and eclipse confirmation.
Yeah, again, I would call that sterics, but because it's able to rotate, maybe they're using the term torsional strain. We'd have to look closer. Not a big deal for us. Do want to make sure that question's right, though. Other questions about any of the material?
Do you have to know how to draw both confirmations?
I didn't draw one. No, and there's also semi-boats or something, half boats. No, we're not doing any of that. I only did chair confirmation. Half twist. Any questions about IR? Did you go on IR? Yeah.
I was just gonna, for the functional groups, a lot of the wave numbers overlap and can be a little, so like, for instance,
Really only the carbonyl region.
right,
Yeah.
are we gonna have to be able to distinguish if,
There's three main carbonyl regions, high, medium, and low.
just between those?
Yeah, high is, what would be high?
Like COCl and
What's the name of that group?
it's just a C-double bond group, and then you have COCl.
Yeah, but what's the name of that functional group?
Acid chloride, is it?
Acid chloride's high carbonyl.
Right,
Ester is a little bit high, but
yeah,
pretty much medium high. Ketone, aldehyde, medium.
those are like the standard medium,
Yeah. Low carbonyl would be
like like my.
Amid, yeah. That's pretty much it. Yeah, there's some overlap, but again, you're never going to be just looking at the carbonyl. You're going to have other information. The entire IR spectrum.
New material, we'll split this in half. Please make sure I get back extras. Question?
We need to know how to draw certain, like, the drugs that you gave us on, like, the worksheets, or will it be given to us in the,
No, you don't need to know structures of drugs. No.
You need to, of course, arrive in plenty of time for the test on Wednesday. If you go take an SAT and you walk in at 7:59 and it starts at 8, they're not going to let you in the door. Okay, probably not at 7:55 either. Because you want to make sure that everybody's comfortable and there's no disturbances for people who are here once we get started. Okay? And particularly with 8 o'clock class, you don't have to wait outside the door and rush in and sit down, so that's one reason I like 8 o'clock class. All right. I know some faculty lock the door at 8 o'clock, etc. I don't typically do that. But we can't be coming in and disturbing people as the test begins. All right? So please be considerate of that. And in terms of procedural things like that, I can also say while I'm thinking about it, thank you, is that some people are not signing in and out of lab. If that continues, I will request a meeting between us and the dean and whoever else to discuss that. Basically, you cannot be in the lab without being signed in, and you cannot leave without being signed out. Okay? This is not something we just do if you want. Please understand that. I thought we had discussed that at the opening of the semester. Other questions about the test today? Yeah.
I just asked a question from the report. There was just a question where it was asking me to name a compound and then have the answer in that, so I just wanted to go over it once.
Name it, and was the answer in the back?
No. It was asking for it, but I didn't see it for that. Number 6, the first one.
Number 6 on page 10. Also name the compound. There's no name in the back?
No, it was for the second one.
Then look on page 10, 10A. Okay, in the back it says name the halogenase
Yeah, it's a
compound.
different question.
Okay, I need to fix that. It's in the front, it says name of all, essentially. You're missing something there. 1,1-dimethyl is not sufficient. It's not correct. Look at it closer. And then ask me again, okay? If you're missing something for one of your complex subs. Page 10 is asking nomenclature.
Okay, guys, I typically would want to start the new material today. I'm thinking I'd like to try something new. We spent a little time here discussing. I would have moved on and we'd be already covering this. I'm wondering if I could cover this by video only. What do you think about covering things by video only there? Such that you can watch at your leisure, re-watch. It would also give us a little more time on, I would only do this with sort of miscellaneous things. Key for test 2 is going to be alkene reactions. And we're going to be always pushing to get the material covered, okay? There's lots of material. If we can do a few things by video, then we have a little bit more time in class and not have to speed so much. I think I'd like to give it a try of covering this by video only. This is some introductory stuff. It's a little bit of review from Gen Chem. It's thermodynamics and kinetics. And half of it should be review, and then we're going to put, the other half is just putting it in the context of organic chemistry. And then like on the back, the reaction coordinate diagrams. Understanding this. Again, one of the reasons I like the video is because I can rush through this, but then that's it. Okay? Video you can rewatch 3, 4, 5 times. And in particular, this is just stuff that really you'd like to spend 2 or 3 lectures on, but we just don't have the time to do that. It's a lot of review. And when I get into review mode, I talk too much because there's so much you can say. I just can't talk that much. So I just have to say, this is it, guys. You got to review it, and that's okay. This sets the groundwork for our reactions. We're doing a little acid-base reaction, but we're going to be doing functional group reactions, reactions with alkenes. This is where we're going to step it up a notch. And the mechanisms will become very important. Hopefully you've invested time in learning your acid-base mechanism. Okay? I tried to stress the importance of that. One mechanism works for any Bronsted-Lowry acid-base reaction. Grading the solubility reports. Some of you have done it very nicely, but too many are not, first off, you're not showing a mechanism, even though the directions say to show a mechanism. The other is just wrong mechanisms. Okay? Arrows mean something. There was a handout in the acid-base which showed the mechanism. It's only 2 arrows for the acid-base mechanism. 2 arrows. And each was explained. Very fundamental for what we're going to be doing for test 2. If you do not understand the movement of the mechanism arrows, you're going to be lost. And you're going to start just memorizing things, and that's just going to make it worse and worse. Just like in math. You don't memorize 52 times 38, do you? No. You can't memorize all your math questions. All right? Mechanism. Very important. Yes?
That's a question about the test. About how many questions will be on the test, and typically do your past students say that they have trouble finishing the test in time?
Some students do not finish, but many do.
Do you know typically about how many questions there will be?
4 or 5 pages. Yeah.
About 10 questions per page? Or?
10 per page?
I'm asking, do you know how many questions
not
per
10 per
page?
page. I mean, some may have 6 or 8, especially with multiple choice.
Okay.
Others may have 2. 2 or 3, I mean. We have 5 minutes left. I can discuss any other questions with the goal of what I'll do is I'm going to put this on a video and have it posted. With the hope that you're able to watch it by Friday morning. Okay? So I know that we got the test coming. can also move to the second handout on Friday, which we'll be doing in class. And then at the latest, then on Monday, I would want to see how we're doing with this material here. You guys covered thermodynamics and kinetics and Gen Chem? Okay. Again, hopefully a lot of this is a review. You did thermodynamic calculations in Gen Chem? Yep. Using like bond strength tables? Yep. Okay. Did you look at reaction coordinate diagrams in Gen Chem, like on the back page? Yeah. Okay. Questions, last questions about the material for tests? Yeah.
Can I show you this?
You got two equatorial, one axial. Two equatorial, one axial. Okay, wait, I've already erased it. What she did here is your ring flip, you didn't do a ring flip. You just changed the position. That was like when I did over here. I had the good one, I redrew it again, and I showed you how you don't have to, I kept the chair the same. I just moved the groups. That's what you've done.
Okay.
And that's okay. Again, what you've got there though is, those are actually mirror images. So it's okay today for us. It's not strictly okay once you understand test 2 material with enantiomers.
Okay.
But again, I told you it's okay. I showed you can do that. You just did it that way. That's okay. It's good.
Okay, and then for this one. I can practice with this, that means hand equatorial. And so is this, would this be? But they're still trans.
Still trans. As long as it's trans, it's good for today. It may be mirror images. Okay? Again, guys, don't worry about mirror images for right now. Both your questions are about mirror images. I don't want to do that because if I say, hey guys, we got to worry about mirror images, then that's going to be a more in-depth discussion, and we're not ready for it. So I'm just having to. You're looking at good stuff, but we're just not there yet, and I'm not going to be holding you accountable for that. As long as they're trans, okay, everything you've done is right. All right, no mirror images. If you understand what that is getting at. Maybe I'll draw a right hand when I should be drawing a left hand. That's okay. I still got a pinky next to a ring finger. It's good. Was there somebody?
Oh, I was going to ask for when we're drawing chair structure thing on the test, do we need to fill in the H's that like aren't related to the heavier atoms? Or is it?
Need to follow directions, and often my directions will tell you to do that.